Welcome back everybody to my advanced programming course using C++. Today we're going to go over dynamic memory allocation using pointers. And I want to give you a little bit of a background in terms of what the difference is between just declaring a local array versus using the operator new. So let's take a look at some code here. Okay, so if you're used to doing things like this, where you are going to declare a variable with a fixed size, this is what we call a local array. So local arrays are created on the stack, and they do have a time limit of when they will expire, meaning that the memory will get destroyed. And that's when the function ends. So in this case, we really don't have to worry about that because we're doing everything in main. So once main stops, then everything else just stops. But if we are inside a function and you declare a local array such as this, after the function ends, you don't have to worry about it. We know that the array itself will expire, okay, once the function is done. With the operator new, we're actually not using stack memory, we're actually using heap memory. So an example of this is what we see on line 11. So what we're doing is we're allocating a dynamic array, okay, and what's happening now is we're creating this block in the heap memory section of RAM. So let's take a look here. So if we take a look at memory, it's two parts. So you'll have a stack and then you have a heap. So heap is, we can call this as a free store. Okay. The stack, not so much, because function calls go on the stack, and so do local variables. The advantage is that you don't have to worry about memory for the most part in terms of declaring variables on the stack, because once the function ends, it gets destroyed. When you are using memory on a heap, much like we're doing over here, we have to make sure that we deallocate the data. Okay. So, and not only that, so if I did this here with 5, at runtime, I can no longer reuse this numbers array. It stays 5 forever. With the pointer variable, and I allocate an array using new, I can delete this and then allocate a whole new set of blocks for this array. Okay, so let me give you an example. Over here, we are going to take whatever the user typed in, okay, and we're going to allocate an array for that. And then we're going to loop through and just enter values. And then after that, we'll just print them out. So let's do that real quick. So let's do 5, and then I'll do 2, 3, 4, 5, 6. So there you see that I was able to insert data into my dynamically allocated array. Now, if I was inside a function, I'd probably want to deallocate this using the word delete. But I'm going to do the delete anyway because first, it's go practice to release memory. Second, I want to deallocate because I am going to create a new array and make it, instead of 5, I'll make it 7 elements. And then by doing that, I'm actually using what to my advantage that when we use the new operator, we're able to resize our current array. Okay, so this is what we call dynamic storage allocation, because it's done during runtime. If I was doing this with just a simple local array, such as what we have on line 5, I could not do this and reallocate the elements. And that's basically one of the differences is as to when you would want to create a local array versus a using dynamic storage with arrays created with new. So if you had to take away something as to, well, why not? I'd rather just use a static array. I don't care. I mean, a local array. I don't care. I mean, it looks like the pointer notation with the new operator is just too difficult, or I really don't see an advantage. The one thing I will tell you is that the stack has a lot of things on top of it. So the more things you put on the stack, meaning aside from your local variables and function calls, and on top of that, you're going to put in arrays, right? The higher the risk that you are going to have a stack overflow. Okay, meaning you're going to pile things up, and then eventually this will you'll get a stack overflow error. The heap, okay, because it's dynamic, you are almost not at a lower risk. I mean, you are a lower risk because the heap is free store, but you really have a lot more to work with the heap memory. Okay, because there are no function calls in heap. Local variables are all stored in the stack. Okay, and at the same time, the heap stuff, the heap memory, every time you use new, you're doing it at runtime. You're not doing it at compile time. So that means that you can resize the array however you want. Okay. The other thing is you don't have to waste space. So if you allocate arrays at compile time, you have to pick a predetermined size. So let's say I want to read through a file, but I don't know how many lines it's going to be or how many lines you're eventually going to have. So for simplicity's sake, I'm just going to say that my array is going to be 1,000 rows. You can't change that anymore. Okay, so if you find that your file has maybe 500, then you have 500 rows of memory space that you've actually wasted. With the heap, you can delete what you initially declared and then reallocate again. So again, the one thing that I would want for you to get out of this lecture is, in terms of using just a local array versus a free storage dynamic allocated array, is that you are gonna run into programs where you have to watch your memory, because again, the stack has a lot of limitations versus the heap, it does not. So if you understand this advantage, then you're better off using more of the heap and having just the small things on the stack. And the last thing that I did want to mention also is that we are talking about a primitive type, meaning you're talking about primitive data structure, which is an array. But a lot of the dynamic lists that are on C++ are built upon this concept of the new operator. So when we get into vectors and lists, they use dynamic allocation to resize the list. So even the libraries underneath C++, they will not use a local storage array. They are going to use dynamically allocated arrays. So it's in your best interest to learn how to use this, and then when you have a chance, try and utilize it. But for the most part, this is not real world application, because in the real world, you'd probably want to use a list or some type of vector data type, which underneath the covers is using the dynamic allocation. Okay, so I hope this enlightened you as to what dynamic array allocation is all about and why you would want to use dynamic array allocation, why would you want to learn about it. Okay, and that actually concludes this whole series of pointers in my advanced programming course. Don't worry, there's more to come. On the next lecture, we'll start talking about multi-dimensional arrays. Okay, I'll see you on the next lecture. Thanks for watching.